Hello world, it's Rahul. So guys, based on my personal experience, I found that no one is focusing on mathematics used behind machine learning algorithm these days. So I came up with this machine learning tutorial series to cover all of that aspect. So guys, let's ask a question from ourselves only. Is there any necessity to learn mathematics for machine learning? In this video, I am going to help you to understand why we use mathematics in machine learning. So guys, machine learning is all about creating an algorithm that can learn from data to make a prediction. And if I talk about some real-time scenario, then prediction could be like who is the person tagged in your Facebook picture, or what will be the target audience for a particular marketing problem. So guys, as long as you understand why we use mathematics for machine learning, it will make machine learning a lot more fun. So guys, with respect to machine learning, we should only focus on some important prerequisites like linear algebra, statistics, calculus and probability, as maths is a huge subject in itself only. And if you want to do masters in maths, then it will take many more years to learn all of that. So you should be familiar with these topics only. Now when I say familiar with, it is not like you have to go and practice each of these topics individually, as you have already studied these topics in your school and engineering days. So only thing you have to do is getting know that how and where you have to apply these knowledge with machine learning use cases. Okay, so let's talk about where we use linear algebra in machine learning. Well, computer interacts with the world very differently. Where we as a human being see an image, computers see a 2 or 3 dimensional matrix. So every bit goes into a computer is a matrix, and that's where linear algebra concerns the manipulation of matrices. That's why we need to know about linear algebra, as we have this input that comes in needs some kind of processing because we are working with the raw data, and that we might have to transform, combine or break down in some ways to create new informative data. So guys, linear algebra makes running these algorithms feasible on massive data set. Again, if you have this set of data which doesn't have any insights and you want to perform some kind of descriptive statistics on that, so you might need to normalize that data, you might want to visualize, or you might want to just mine that data to find out where to go with the next. So guys, probability and statistics come under modeling part, where statistics is the core of everything and probability helps to predict likelihood of an event occurring. So you can build predictive model. Then you know why you are using linear regression, what are the strength of linear regression, when would you use logistic regression. So now we have made the model, but we need to optimize that to make it best version of that model. But how we can do that? So we can measure the error function. Bigger the error means model is not that much sounding. So we use calculus to refine the optimal way of reducing the error function. Let's quickly understand where and how to use mathematics in machine learning by using one example. So suppose I want to learn about linear regression, which is the first and most basic algorithm, and I guess probably everyone will learn. So here my goal is that I should be knowing how this particular algorithm works. Now when I say how this particular algorithm works, that basically means that I have to go and see what is the problem scenario we are going to solve. So guys, suppose x-axis is my years of experience and y-axis is my salary, and data is scattered over the Cartesian. So I have to predict the salary for a particular year of experience, as you can see on the screen. So in order to solve this, what I'll do is try to create a best fit line according to the linear regression. And this line is basically drawn by knowing factor, that is y is equal to mx plus b, which is nothing but the linear algebra. Now as soon as you see this equation, you'll remember that you have already studied this in your school days. So it is just you have to recall these things at the moment. No need to do practice on these equations. And the best thing is you are recalling this by seeing some practical implementations. So that's good for you as well. Just imagine in school days while we were learning this equation, we hadn't any clue that why and where we are going to use this equation. Only having one understanding that for creating a straight line we have to use this equation, and that's it. So now automatically your interest will be more to understand and deep dive into these equations as you are understanding the practical use of this. And now you will be able to understand what do you mean by term m and b, how do we calculate the exact value of m, because I can draw many straight lines on that, but which is the best straight line? So for getting value of m, we have to understand the gradient descent that I'll cover in upcoming session. For as of now, let's understand that the m value shown in the figure should come over to the minima highlighted with the red dot. Then only I'll be able to use it. But why here only? As my slope is basically 0. And when I say slope, calculus came into the existence. And now you will came to know the actual use and implementation of derivations, what you have read in your college days. So guys, it's not like you have to study math separately. You just have to understand the use case and basic of mathematics. Only thing is to apply it correctly. So guys, from next session onwards, we'll start understanding what is machine learning, what are the types of machine learning, supervised and unsupervised machine learning algorithms. Thank you guys for your time. Do like, share and subscribe. Hit the bell icon to get the latest updates. Happy learning and stay safe.